do I make? Oh, there we go. Okay. So my talk is called Hypothesis-Driven Design. We're going to get a little bit experimental today. Again, before I start on my talk, I wanted to give you some background so you get an idea of how I approach design. And we touched on this in the panel talk. You know, I have experience in science, art, and design. You know, I said I have a physiology background. I spent a semester studying the salivary gland enzymes of ticks. So it makes great party conversation. We can chat about that later. I know you're riveted. And then I studied biomedical illustration and visualization. So that's the art sphere. And then I got more interested in software design and user experience. So that's me. I live in this intersection here. And I try and bring some learnings from each discipline into my user experience design practice. And that's why I call my talk Hypothesis-Driven Design. So what I'll be talking about is a little bit of background. I want to give you an idea of some of the processes that have led us here. I'll talk about why you should use this technique, what it is, because you'll want to know that, when you should use hypothesis-driven design, how to define and test your hypothesis, and some takeaways. And I wanted to start the talk off on a sad note. This is this quote by Will Evans. So he says, the problem with many startups, and big companies too, is that you spend months or years doing research, writing requirements, designing and building software, and then you discover that no one cares. And that's sad, but how do we get there? Like, how does something like this happen? Well, let's look at the traditional product development process. You have your product managers, they're defining something, okay, they're done. Now we're kick it off to designers and we design something, okay, we're done. Kick it off to developers, they build it. Now we deploy it. Now the team goes out and drinks, and it's only then that you get customer input. And this is like traditional waterfall type of design. And this is dangerous because at every step, everyone from designers to developers to stakeholders like product managers or clients has assumptions about how a product should be built and what a product should be. And with this kind of protocol, those assumptions get built in at each time. And if they're wrong, by the time you get to the end, then the customer sees it. Oh, then you have to go back if you learn anything and go through it again. You're wasting a lot of time and a lot of money because no learning happens until after you've deployed to the customer. So there's a lot of risk here in building the wrong thing. Now, I'll give you an example. Sorry if you're from Microsoft today. I don't know if anyone here is, but this example is the Microsoft Bob operating system. You probably didn't work on this. It came out around 1995, pre-Windows 95. And what it is it's taking kind of desktop paradigm to the next level. So your operating system is a house, and like the Rolodex is your address book, and you've got your books up there, and you have a dog that guides you. So it kind of failed. It was designed to be this user-friendly operating system, you know, but I don't know if I'd want to use this. So really the key to a great product is having a problem you're trying to solve, and they got that right. They wanted to make a user-friendly operating system. But it's important to remember that you're not your customer. So what Microsoft thought was user-friendly, perhaps, you know, an accountant working on their year-end report might not want to use this. It might not be user-friendly to them. This would be great for kids who were just getting started on learning computers, but in 1995, it didn't really catch on. So only through customer contact, through customer research, can you really uncover customer needs. And you know, Windows 95 came out and they kind of forgot about this product, and Windows 95 was a success and people are still using it somewhere, I'm sure. So, you know, the industry's learned from this, and a guy called Eric Ries wrote a book called The Lean Startup, kind of addressing that waterfall issue. You've got Agile coming up. And Jeff Gothelf adapted this to be Lean UX, so user experience in the context of Lean Startup. And so this is a diagram from that book. You've got these cycles of building, measuring, and learning that you're kind of doing iteratively. So you think of an idea, you come up with an idea for your product, a design you want, then you would make a prototype or some artifact to test it, then you check it with customers. And the key to this is these small iterative loops. And you see a similar ideology if you look at Google design sprints or IDEO design thinking. If you look this up on the internet, you'll see probably like different versions of circles that go in on themselves and circles that go into other circles. But the whole thing that all these processes have in common is short cycles of iteration. So you're not waiting till the end to learn from customers. You're learning all the way along. So this really resonated with me as a user experience designer. I'm like, yeah, I get this. And as I thought about it more, I noticed something. It really reminded me of the scientific method. And if you're not a science person, maybe if you think back to middle school, you probably learned something along the lines of this. You know, you come up with your hypothesis, then you make your little experiment, then you get your data, you analyze it, and you come to a conclusion. So there's a lot of overlap here. You've got, research, measure, conclude. It's these same phases. And I looked at this and I was like, oh man, science to the rescue. It's not scary, so I'm not going to make you do statistics. Don't worry. We're just gonna dip our foot in science here. So I was looking up UX processes, and that's when I came across this, using a design hypothesis. So we're kind of going to meld fields here. So what's a design hypothesis? It's simple. You just take an assumption or a concept that your design's based on, something you think's true, then you phrase it in a way that allows it to be proven or disproven with research and experiments. And then the results of these experiments are going to tell you whether you understand your user's behavior or any potential pitfalls of your concept. And it's a way of formulating those iterative design principles, those cycles of making and learning. And just like we have in the scientific method is a disciplined way of turning guesses into knowledge. And a design hypothesis is a way of turning maybe your design guesses, your assumptions, into verified knowledge. So why? Why should you use this? Well, first of all, it can be collaborative. We touched upon this in the panel a little bit. But again, each team member, whether it's a developer or a client or product manager, they all want different things from the project and they all have different priorities. So by doing this together, you can agree on why you're doing something and agree on how you're going to do it. And that goes into the next point. You can get this cross-functional team buy-in. I think one of the most frustrating things is if you're ever in a meeting where maybe it's with a client, maybe it's designed by committee, which is the most irritating thing. And I think that happens because people want to give you feedback, but they don't have kind of the channels to do it, so they're trying to do it through designing something. But what you can do here is get everyone involved in writing this hypothesis, and that way everyone feels ownership and involvement in the design process from the start. And I found personally then when you show the designs that you've come up with, there's less need to get buy-in, there's less need to sell your vision, because you've kind of involved people from the start. And again, another benefit is this can be evidence-based. So in science and medicine, this is a big thing. You want to back up your opinions with evidence. And here, in this context, you can get informed insights on your design decisions. So if you do need to kind of say, well, imagine someone's like, well, why should we use this design? You can say, well, here's some informed insights from our customers as to why we should proceed this way. And if you're a product manager, this can help kind of infuse that customer feedback into your roadmap. So you're getting feedback from customers all along, and you can kind of cater your roadmap and make certain changes along the way. And it also gives you this holistic approach. I know for me, if there's this very open-ended design problem, I can make 20 iterations and I can go back and forth and never make progress. But I think as designers, we thrive on constraints. So this type of process can give structure to your design explorations. It can put some constraints on it from feedback that you get from customers. And you can quickly validate concepts. So if you use this early on, maybe you have 5 versions of something, whittle it down to 2 and proceed with those. So when are you going to use these hypotheses? When I think about design problems, I like to use this double diamond model. So you come up with kind of a vague problem, and you go into this divergent phase where you do a bunch of research about what's the context of this problem, what does it mean? And then you kind of narrow down to a problem statement, or you might make a design brief for a client of, this is the problem we're going to solve. And then that's designing the thing right. That's when you're figuring out if you're designing or building the thing right. Then the second diamond is, are you designing, sorry, I got that backwards, you guys. Are you designing the right thing? That's the problem. Then you go into designing the thing right. That's when you're building it. So you come up with a bunch of design ideas, and then you whittle it down to the solution. Oh, it's just too many words there. But this is where you can use the hypothesis-driven design in the second half of each diamond. Better not mess up those words. Is the concept right? That's when you can use it in the first diamond. Is this concept worth pursuing? It's easy to come up with a bunch of design ideas, but are they solving the right problem? Then the second half of the diamond is the solution right? Is this solution worth pursuing? And hypothesis-driven design is not the same as usability testing or testing a design pattern. You're not really trying to figure out if this thing is usable or workable. It's more, is this the particular solution we want? All right. So how the hell do we do this hypothesis thing that I've been talking about for 10 minutes? Let's get into the nitty-gritty. So how to create your hypothesis. The first thing you need to do is identify your assumptions, because the hypothesis is what's going to help you prove or disprove these with the experiment. Now, I know you're designers. I know you love Post-its. This is your chance to get out your Post-it collection, engage with your team, have a Post-it party. So get the whole team, if you can, devs, PMs, clients, if applicable, to participate, because everyone's got different assumptions and different points of view, and have people write them out. And you can use what I call the 4 W's to help spark the conversation. So who are your customers? What are their problems? What sphere are you solving it in? Why this particular problem? What do you know, and how do you know it? So you get these assumptions out, and you'll be able to probably cluster them into some kind of groupings, and you'll use these to formulate a hypothesis. So this is a little template that I've come up with. So you'd word it as such. We believe that creating this experience or building this feature, this thing, this is where you put your assumptions for this persona or customer will achieve this desired outcome. So this is where you put what you want the user to do or you think the user's going to do. And this is the important part. We will know our hypothesis is valid if, and then you put in a measurable metric. So you need to have some measure to say whether this is successful or not. So let's look at a little example just to illustrate this. Vacation rental app. So I have my spare room and I want to rent it out to travelers, or, I live in Toronto, so I can probably rent out my crawl space to people. The economy is that way. I might be making this app, and my mom, if I'm ever renting with one of these apps, she's like, are you sure that's safe? Like staying with a stranger? And I think there are a lot of people out there like that. So people who are skeptical. So what a designer of an app like this might say is, well, what if we have verified hosts? What if we vet the identity of hosts or vet their listings somehow? A hypothesis around that might be, we believe that having this list of verified hosts for potential renters will make skeptical renters, like my mom, more likely to book. So you're framing your design as this kind of question. So we'll know our hypothesis is valid if potential renters choose these verified hosts over equivalent other hosts for 60% of their bookings, and if over 50% of undecided renters say that they're willing to book with a verified host. And these numbers, I just kind of made those up and put those in. Those are not scientific, because it's up to you to define what your criteria of success or what valid is, and you just need to kind of come up with that for your product. And this hypothesis is kind of is the problem right? Is this list of verified hosts going to address this problem of skeptical renters? And it's good to have multiple hypotheses. So a follow-up could be, we believe that having a list of verified hosts for renters will make renters feel more comfortable about their stay. And this hypothesis is in the second part of the double diamond. So is this solution the right solution? Does it make people feel more comfortable? And we'll know our hypothesis is valid if over 80% of renters say that their stay was a positive experience and accurate with the listing. So that, again, is a criteria of validity that I've put in there. So we'll return to these. I want to talk about how to test your hypothesis now. Before we get back to the examples, the first important step that you need to decide is what kind of feedback you're going to need to prove or disprove your hypothesis. Identify what you want to learn and pick the method of least effort. Don't make a high fidelity prototype if a paper prototype will do, because you want to be testing frequently. So I'm sure I made this little grid. Probably you all know qualitative data, quantitative data. I've added like these rows of behavioral, so what people do. So qualitative behavioral would be observing, a site visit. I lump a prototype in here. You're observing people doing something. Quantitative behavioral would be analytics, metrics, that type of thing. Attitudinal data would be what people say, how they feel, what their attitudes are. So qualitative attitudinal would be interviews with people. Quantitative attitudinal would be surveys. So you could ask people on a scale of 1 to 10, how did you like my product or service? That type of thing. And I wanted to give you a little greatest hits of Leslie's research methods for hypothesis. So I wanted to talk about the research methods a bit. So if your measure of success is related to people's reactions and attitudes, you want to use qualitative. For qualitative, interviews are great. You can use face-to-face interviews, but I've often found that these don't lead to those serendipitous insights. They don't lead to the aha moments. So I really like doing co-creation activities better, like journey mapping. If you've got Post-its left over from your assumption activity, now's your time to bring those back out, get your clients in the room or your customers if you can, and have them map out their journey through whatever process or service you're designing, their pain points and any touch points. I found that it's just a better way. I've gotten better insights doing that. Then you might also do observation. And when you think of that, you think of site visits, but I also lump prototypes in there because you're observing someone interacting with something. So you have to ask yourself, what level of fidelity of prototype do you need? You can use low fidelity, like a paper prototype. These are great because they're low cost. You can test concepts quickly without coding. You can get early, frequent feedback from your customers or your cat. Or you might choose to do medium fidelity, again, use Envision, Acture. There's like a million tools out there. You can use whatever you like. But these are great for validating a workflow or testing a particular interaction. And if you're looking to use quantitative methods, this is what you would want to use if your metrics of success are tied to measurable outcomes. So for example, a purchasing workflow or a sign-up workflow. You can use surveys, you can use metrics like Mixpanel, Full Story, Google Analytics. I'm not going to talk too much about using those. But I wanted to get back to our examples. So the vacation rental app example. We want to see if potential renters will choose the verified hosts over equivalent hosts for 60% of their bookings, and if over 50% of undecided renters say they're willing to book with a verified host. So how could we test this? Well, for this, I would make a prototype. It doesn't need to have real data. You could make fake listings of different criteria and have people come in and ask them which places they'd choose. If you have developers around, they could make an actual data prototype. You could run studies with skeptical customers, ask them questions as they're looking at the listings about what they would choose and what would stand out to them. So I would use prototyping for this hypothesis. For the second one, we'll know our hypothesis is valid if over 80% of renters say their stay was a positive experience and accurate with the listing. Well, for this, you'd probably run a post-booking study or survey, ask people about how they felt about their stay. You can also look at what reviews they would leave on your app. What did they say about the listing? You can ask them to rate the listings on certain points like accuracy or cleanliness. And it serves two purposes. Those ratings, and lots of these apps do this, Those ratings are good for people who want to book it next to get accuracy, but it's also good for us as designers to see, oh, these are popular and people rate them high in these categories. So it gives you a metric of what people like from those listings. And I wanted to talk a bit about what I do at Autodesk and how we use these processes there. So I currently work on something called Autodesk Fusion Production. I'll phrase it like this. It's like the Nest for factories. So a Nest is an IoT thermometer. I'm sure you all know about this. You put it in your home, and remotely you can remotely monitor kind of the temperature of your home. You can change the temperature. It can give you alerts if your house is burning down, so you know. So what Fusion Production is, it's like that for these big factories. So in these factories, you've got these parts, these big metal parts, and they're going to each of these machines to get milled or cut. And our product, we hook these machines up to the internet. So, you know, it's hooked up to the internet to Fusion Production, and we're monitoring what parts are on the machines. Are the machines working, or are they broken? And we've also got a mobile app, so you can see machine operators down there. We would give them the mobile app, and they can scan the parts that are going in the machine to track, and they check off things that they do. And right now, you can see in the picture, they've got clipboards. Most of these factories are paper-based, and it's super inefficient because the manager is like, where is the part? And they have to run around and find it on the shop floor. So we're trying to digitize this and make factories more efficient. So our measure of success, I just said, was based on efficiency of the shop. So one metric for success for us was, how many more tasks can a machine do? How many more jobs can a shop take on once they adopt our product? And that's a measure of efficiency. Another one was, how much more time do the machines spend running versus being idle or being broken? That's another measure of efficiency because the managers can attend to these like broken machines faster. And a lot of these, because we're this kind of data collection software, we're able to use Mixpanel to track a lot of that quantitative information. And we also did some tracking of qualitative around perceived efficiency. That was really interesting because a lot of managers thought their shops were at maybe 40% or no, 60% efficiency, but they were actually at 40%, and they only learned that when they started actually tracking things. So that makes a compelling case to sell the product because it's like you may think your factory's working one way, but with this, you'll realize it wasn't, and you can improve on it. So you might be thinking, this sounds like a lot of work. How much research do I actually have to do? Well, Jacob Nielsen, who's a big, you probably heard of him, he's a big UX guy, he suggests that 5 participants are sufficient for qualitative research. And in my opinion, I think 10 is a great benchmark, between 5 and 10. After 10, your kind of return on investment levels off because people say the same things, you hear the same problems. So really, that's kind of the golden area. You don't need to do too much more than that to get some insights. But the most important data point here is that one. If you don't do any research, you don't get any insights. So any amount of testing is better than none. You can be informal, you can go guerrilla, you can go to the coffee shop and find people if you can. I went to the coffee shop and tried to find CNC operators, but none showed up. So it depends on your industry. Some of us have more trouble than others, but 5 to 10 people, it's not that hard to find them, in my opinion. So you get your data, now it's time to analyze and refine, and this is where you want to learn and improve. So what you might find is if you run your experiment and you don't know if your hypothesis was proven or not, your metric might be wrong. So you may have not structured your prototype properly, or your survey might not be worded properly. So you might need to go back and refine your experiment and run it again. You might find that your hypothesis is false, so be prepared to change direction. And that's why I suggest doing this frequently and early, because if your product's going one way, it's really hard to change direction when it's too far along. But a bunch of little changes in direction are much easier to make, and they're much easier to kind of sell to your product management and dev team. And I wrote here, failure is an important part of learning. Like, you should be constantly learning and improving, and failure and experimentation are really key here. I wrote value the gap, because it's not the data that you're getting from these experiments that's valuable, it's the questions that come out of it, the gap between what you thought and what you saw. So it lets you know where to focus your effort. What did you think you knew that you don't really know? What was your assumption that was proven wrong? That's really where the value of this technique comes out. And I've got a quote here from Donald Rumsfeld, former Secretary of US Defense. If you're an Errol Morris fan, he's got a documentary on this guy. Donald Rumsfeld said, "There are known knowns. These are things we know that we know. There are known unknowns, that is to say, there are things we know we don't know, but there are also unknown unknowns. There are things we don't know. So it's very verbose, but the unknown knowns are what I wanted to draw your attention to. You don't know what you don't know. So what this technique brings to light is by this testing of a hypothesis and the questions that come out of it, the goal is to make you aware of the things that you may not have even thought about before, the unknown unknowns. That's the key. And I wanted to give you a few things to be mindful of when using this technique. So you'll never know with certainty how your product's going to be used unless you build it. I've met with product managers or work with them, and they're like, oh, this is a great way to vet our product in the market and ensure success. Well, it's not bulletproof in that way. A good analogy that I like to give is Newtonian Physics. So Newton kind of formulated, we thought we knew how gravity worked, we thought we knew how matter worked. We went hundreds of years thinking that, and then Einstein came along, Schrodinger came along, quantum physics was a thing, and they're like, oh, you know what? Matter doesn't behave how you thought, and gravity, not really either. So if our fundamental understanding of matter can be proven false, then be prepared that your product hypothesis may need to be revised as well. And I also put it's hard to pick up on weak signals. So if you have a dedicated user researcher, you don't have to worry because they've got a lot of experience probably and they've been trained in it. But if you're in a startup, you might be doing this yourself. If you're new to the industry, sometimes when people don't understand something or they're struggling, they'll be a little bit reluctant to let you know because they'll feel self-conscious that they can't do this thing when really it's probably a problem with the software. But it's hard to pick up on those weak signals. So it's just a matter of being mindful when you're testing, not leading people, and trying to pick up on what they're trying to tell you. And then another point, the longer you spend on a design, the less likely you'll be to discard it. So try to do this testing early before you've invested too much in case your hypothesis is false. That leads to the second point, which is keep it lean. So test often and make it easy on yourself. Don't make it a big thing to run a test. Do easy tests with paper prototyping so that you can do it often and really kind of integrate it into your process. Because you don't want to wait till the end to do the testing and learning. It needs to be part of your day-to-day process if you can fit it in. Now the last point, this kind of goes to speak to the idea that we were talking about on the panel of data. I have to get a little water. So this hypothesis-driven design, it's not about regimenting a design process. It's not about codifying all of design. It's not meant to stifle creativity. It's meant to take data to validate your design decisions, verify things you thought were true. You should still be able to be creative and come up with a bunch of design options, but this technique should be used to help you address and whittle down maybe potential solutions, help you, if you've got questions, answer those. So don't let it's not meant to stifle creativity. It's just another toolkit for measuring the success of your designs. Because design is subjective, of course, there's no one right design, but some designs and some concepts work better for certain audiences in certain industries. And that's what this is geared towards finding out. So I just wanted to conclude with, background, don't be Microsoft Bob. Hope I covered why. Hope I covered when and how, some takeaways, and I wanted to leave a few minutes for questions. If there's not time, those are my contact infos there. But I think we finished early enough to have a couple questions. Go for it. Except you have to remember. Repeat question for audience. Okay. Does anyone have a question? Oh, in the back. Mm-hmm.
But then it seems like the metric is coming from data, and since those data usually get it a little later within the process. But then you mentioned we need to do the hypothesis and test it often, right? So it seems like the hypothesis we are testing, we can't always use those measurable metric to test. So how do you find that balance?
It depends. I guess some of the quantitative stuff you can't do until later, but you should be able to measure some of those metrics earlier on. When I was talking about, for example, the vacation rental app, I didn't repeat the question, I will next time. When we're talking about the vacation rental app with the first part where you'd have a prototype and would 50% of people choose this or that, well, what you could do is you would be, you'd have the prototype, you'd be asking users questions. If you have 5 or 10 people, you'd record kind of their answers, and, then you would split, did half of the people say they'd rent? Did half not? So you can you can get those metrics out of qualitative data, or, if it's a survey, did somebody enjoy their stay? Well, if they said they enjoyed it, like if you surveyed 10 people and 5 said, yeah, the stay was great, well, then you have a 50% success rate. So it's not always about quantitative data. You don't need to be too prescriptive about it. It's just, the real goal is you need to definitively know if this thing is working or not. So I don't want to be so pedantic that it has to be this amount of data, but you should have a way of saying, you know what, this is right or this is wrong. And it can be more qualitative. It's okay for it to be a little fuzzy. Yes?
So question about designing the right thing. So I think it's more or less clear, like how to check if you're designing things right. It's like more or less common. But about am I designing the right thing? It looks like it should be answered even before you kick off your design. So let's say PM works on the backlog, and when PMs put something in the backlog, they should know, is it the right thing they need to put there? And so it looks like it's not the designer who needs to answer this question, ideally, right? Because like if PMs are not sure or they didn't check that they want to do the right thing, they spent already like time and your effort.
Yeah, so the question is designing the right thing and picking out what features, what problems we want to solve. Should that be a PM question? That's where I think we get collaborative. So that's why you bring PMs into this process. So that is typically how we would work at Autodesk, is we work really closely with the PM. So when we're mapping out a roadmap, the PM owns, they're the product owners, they would own that roadmap, but our user researcher actually goes out with the PM and does kind of this generative research. So the PM might say, we need feature X, Y, and Z in our product. And our user researcher will actually go out and do interviews and not co-creation, but generative research activities with customers to actually see if those are the right features to target. It's a different type of research. That's when you get more of that interviewing type of thing, or you might do a survey. You're not making a prototype, but you're trying to see if those particular features are actually solving the user's problem. Because the great analogy is, if we asked people Henry Ford, if we asked people what they'd wanted, they'd say a faster horse, but we're going to give them a car. So you go out and you ask people, well, what are your problems? And then you say, well, is the feature the PM is suggesting going to solve that problem? And it ultimately is them owning it, but it's a great point of collaboration I've found with design and PM. So we're not just picking stuff out of the backlog and designing it. We're really working with them. And I've worked with great PMs, so they've been really open to that. Any more questions? One more, yes.
Did you construct the double diamond?
Did I construct the double diamond? No, I did not. I tried to put some citations. You can find it on the internet. It's like a really common way of thinking about stuff. That particular one I got from UK Design Council. There. Yeah, if you Google double diamond, you'll see all sorts of variations. It's not something I made up. It's like it's kind of a methodology of thinking about problems and things. Can't take credit for it. I can take one more question if anyone has. No? Okay, thank you very much, everyone.